So we've already done examples in the previous two videos that match your homework problems 1 through 8 pretty closely. So I'm not going to go over those again. They're just essentially giving you this, when you make the matrix out of the basis vectors and multiply it by the coordinates in the basis, that you get the standard basis, and they're either giving you this one and asking for that one, or vice versa. That's all of 1 through 8. Starting with number 9 through 14, there's nothing really new computationally, but there's some new language here. So let's talk about some of this language. In 9 and 10, they say find the change of coordinates matrix. That's a new term. From B to standard basis. But let me just point out that's exactly what we've been doing in all of 1 through 8, is we've been taking coordinates in B and turning them into standard basis coordinates. The matrix that does that is the basis vectors as a matrix. So in other words, on number 9, if they had said, which they didn't, but if they had said, do 2, 3 in basis B, you would have done that times 2, 3, and that would have produced 2 of the first vector plus 3 of the second vector, which is the same thing as going, see if I can do this right, 8, -6, and 15 is 9. It's the same as going 8 over and 9 up in standard basis. So this little guy right here is the change of coordinates matrix. It's just new vocabulary. What do we mean by the change of coordinates matrix? It's the columns of the basis, but slapped together into a matrix, because that's exactly the matrix that you multiply B coordinates by to get standard coordinates. It changes the coordinates from B to standard. So I think that was number 9. Sorry to take the joy of discovery away from you, but number 10, I think you could probably write down the answer right now in a similar way. 11 and 12, they say use the inverse matrix to find xb. So this time they're asking you to come up with this part, and notice the equation, the vector matrix equation you're trying to solve. Would be this one. And we certainly could solve that by an augmented 2 by 3 matrix and row reduction. They're just specifically asking you to instead find the inverse. So if this is B, we need B inverse multiplied on the left and B inverse multiplied on the left. So you'll just have to go through the process of finding the inverse. They just want you to not forget the inverse, basically. And you can find your change of basis, your basis coordinates for B that match standard basis of 2, -5. This is also a little bit of foreshadowing from when I mentioned jumping straight from one basis to another basis without going through standard first. But again, for now, they just want you to find the inverse and go from there. So 13 and 14 are somewhere they're giving you bases for P2. And they want you to find the coordinate vector for some other result. So really, they're still saying something times 1 plus t squared plus something else times t plus t squared plus yet something else times 1 plus 2t plus t squared. Should be able to produce 1 plus 4t plus 7t squared. And you could probably figure that out. Like a good Math 97 student should be able to figure this out, but we did not get into math to do things the Math 97 way. So of course we've got a little more efficient way to write this. You can write your R3 vectors in any form. I kind of like doing the second degree first. So I'll do 1, 0, 1 with t squared on the top. So that would make this one 1, 1, 0. And that would make this one 2, 2, 1. If you like doing it the order they supplied it, there's nothing wrong with that, as long as you remember where your t terms are, where your t squared terms are, where your constant terms are. And that needs to come out 7, 4, 1. And now you can find the inverse and multiply both sides, or you can row reduce, or however you like to solve that sort of thing. 15, of course, is the true and false. And that's the whole assignment, 1 through 15. Notice I did give you 1 through 15 all, not evens. So I do want you to do not odds. I do want you to do the evens and the odds, 1 through 15 all. And we will, again, this is just locking down the fundamental idea of what a coordinate system is, and we will continue to build on that in the next few sections.